Fields is in a special place on the spacecraft. The electronics package is inside the spacecraft where most of the electronics are, but all of our sensors are mounted on the outside of the spacecraft. We have 3 sensors that measure magnetic fields that are mounted on a boom behind the spacecraft in the shadow shield. And then we have 5 sensors that measure plasma voltage. These are electric field sensors. They extend into full sunlight and they get very hot. 2 of the key measurements to understanding coronal heating are the measurement of the magnetic field and the electric field. And together they give us what's called the Poynting flux, which is the energy flux of the corona. And to make those measurements, we have to actually go into that plasma and put sensors in the plasma to measure magnetic fields and electric fields directly, and that's what fields will do. Solar wind is the escaping atmosphere of the sun. It's the escaping corona of the sun. The corona is heated in a way that we don't understand yet, presumably involving magnetic fields, by energy that comes from below in the photosphere. And it's heated to such a high temperature that it can escape the gravitational potential of the sun and become an escaping wind, a stellar wind, a solar wind. Well, the design of the Fields instrument is a new thing for solar wind physics. It kind of combines 2 previous styles of experimentation. There are 2 ways to measure electric fields in space. One is using a technique that's called a double probe. And there's another technique which is measuring plasma waves or radio waves. And Fields for the first time brings these 2 techniques together. I think the very first data that we get will be revolutionary. At first blush, it'll just be a bunch of numbers as a function of time. But the science team, will take those numbers and make visualizations in the form of spectrograms, and eventually those data will be related to models, and so we'll be able to compare directly 3D visual models of the coronal magnetic field. These measurements have never been made in the environment close to the sun. We've made measurements similar to this in the Earth's magnetosphere, Earth's ionosphere, but putting a package like this into the solar corona it's just never been done. The closest anyone's ever been to the sun, and based on what we've seen so far from spacecraft not quite as close, it's going to be striking and I think revolutionary.